Greetings, Mathies. This is Mrs. Mounts, and today I am going to go over solving equations that either have one, no, or infinite many solutions. So here we go. All right, I'll get set up here. I enjoyed those thoroughly. All right, here we go. Let me get my screen set here for you. Okay, you have the note sheet. So you can see we're going to have equations today that have one solution. That's what we've been doing so far. But we have a couple other different situations where we could have infinite many solutions, meaning we could substitute anything in and it would make the equation true on both sides. Or we're going to have no solution. There is absolutely nothing that will make this equation correct. So let's just review when we have one solution. This is a two-step equation. So I'll get zoomed in here a little bit for you. And I'm going to go ahead and use that new method that I taught you. We're going to make rectangles. You can even do this on a two-step equation. So remember, variables stay on the left, constants stay on the right. So our variable is 3x. Don't change the sign or anything. It just stays. 14 on the right-hand side. That's a constant, so that just stays. We have to subtract 7. The inverse of subtracting 7 is to add 7. Or you can think of opposite. We have to take negative 7 to the opposite side. So we are going to add 7. So again, I just think this really keeps you organized. 14 plus 7 is 21. And we get x equals 7. And that's a one solution. So that's just a review. So you can still, that could happen on the assignment, that you just get a solution. But let's look at when we get infinite many solutions. Think about your flip book. If it says that you have grouping symbols, we need to use the distributive property. So we're going to do that. Now I'm going to draw both arcs because I know you'll get that 3a, but we have to remember to take 3 times 1. All right, so I'm going to make the rectangle. And let's see what happens here. So 3a is going to stay. I'm going to put v and c just to remind you. Variables stay, constants stay. We're going to take plus 3 minus 5 to the opposite side. So we'll do the inverse operation, minus 3 plus 5. And then we have positive 3a. We're going to take it to the other side, minus 3a. So let's simplify and see what happens. 3a minus 3a, oh, that equals 0. So the variable ended up canceling. Let's see what happens on the right-hand side. Negative 2 minus 3, that gives you negative 5 plus 5. Oh, that also equals 0. So let's see what it says over here. It says all real solutions. So it's infinite many solutions. And look, we have a number equals a number. 0 equals 0. So that means we can substitute anything in and it would stay the same. Now I want to just go back to this line. 3a is your constant, or I'm sorry, is your variable. Plus 3 minus 5, let's simplify that. So we would get 3a minus 2. And look at what we get on the other side. Okay, so once you identify that we have symmetry here, you can automatically say that it's going to be infinite many solutions. Now, if you don't notice that and you still do the rectangles, this is what eventually is going to happen. But I just wanted to show you that. So it's the same thing, same expression on both sides. Let's check out what happens with no solutions. So maybe you can make a prediction here. I kind of have a little side note here. So let's go ahead and distribute with the flip chart. If we have a grouping, we want to go ahead and distribute. Negative 6 minus 9x. On the right-hand side, minus 9x minus 4. Let's do the rectangles. Negative 9x stays. That's your variable. Your constant, negative 4, stays. And I'll go ahead and cross them out on this one just to help us keep track. The inverse of subtracting 6, or the opposite of negative 6, is to add 6. And then the inverse opposite of negative 9x, we're switching it to the opposite side, but the inverse of subtracting would be to add 9x. Okay, let's see what happens on this one. So look at the variable cancels. We get 0 equals negative 4 plus 6. Oh, that's 2. And in math, that is a false statement. Okay, that is false. That is not equal to each other. So we know that this particular equation would have no solution. Now again, I'm going to go back to this step right here. I'm just going to rearrange a little bit. I'm going to bring it down here. So I'm going to put the variable first and the constant. Variable first, then the constant. If you look at this, we have negative 9x on both sides. Same variable, so those would cancel each other. And some of you then may see, oh, negative 6 equals negative 4. I don't think so. That can't happen. So some of you may see, if you have the same variable on both sides, same sign, then that would cancel. Then you look here. If they are different, it would be no solution. If these would happen to be the same thing, then it would be all solutions. Go ahead and glue this in your notebook, ... and we'll work on some problems and see how they end up turning out.